So today we are going to be discussing on Carbanion. So Carbanion is one of the most important parts of organic synthesis. That is, first of all, when we talk about Carbanion, we should have heard what we meant by ions. So when we talk about, we have two kinds of ions in our basic elementary chemistry, where we talk about the cation and the what? The anion. When we talk about cation, it means a positively charged ions, and the anion is a what? A negatively charged ion. So on this basis, you have the idea of what we meant by cation and what? And anion. So now in the terms of organic chemistry, that is when we talk about carbon, which is one of the most, it has some unique characteristics, that is, it is said to be what? Tetravalent. So that's one of the uniqueness of what? Carbon, that is said to be what? Tetravalent. Now when we now say carbanion, when we talk about carbon and what? Anion. So carbanion is derived from the word carbon and anion. So now carbon, that is, when in simple terms, we can simply say carbanion is a carbon with a what? With a net negative charge. When we say what? Carbanion is a what? Is a carbon with a negatively what? Charged. So now the word carbanion is now derived from, we can now see, that is carbanion, that is carbon with a what? Negative charge. So in simple terms, we'll be able to introduce what we meant by what? Carbanion. So in another scenario, we can say carbanion is an anion in which carbon has shared pairs of what? Of electrons and bears a what? A negative charge, usually with a 3 substituent. So now let's just show how we can derive carbanion. So let's use an example. We have this. As we all see there, that carbon is said to be what? Tetravalent. So it has 4 binding sites. We have this. So to generate a carbanion. So the next question is, how are carbanions being what? Being generated. So now how do we form carbanions? For example, we said they can be formed. The first one is that they can be formed from what? They can formation of carbanion. That is the formation of what? Carbanion. The first one here is what? Deprotonation. So that is, we talk about the first one is what? Deprotonation. So what kind of compounds, what kind of groups can we what? Deprotonate? The groups we can deprotonate are the alkane group, the alkenes, the alkynes, so and so on. So the simple terms with which carbanions can be what? Formed is what? Is through deprotonations of our alkanes and alkenes. Even our arene self, they can be formed by the deprotonation of our arenes and what? And alkynes. Very good. So now, in simple terms, they have a concentrated of electron density at the negative charge carbon, which in most cases reacts with varieties of what? Electrophiles. So in simple terms, so let's use an alkane as an example. Let's use this as an example. We have this particular compound. So now, let's use as an example. So now, to deprotonate this compound, it is very easy. So you can, through bond cleavage, through the cleavage of bond, through bond cleavage, you can see here we are left with this and this. You can see our carbon possessing a net negative what? Possessing a net negative charge. That is carbanion, carbon with a negative what? Charge. You can see carbon with a what? A negatively what? Charge. So now the next one is, we need to discuss some common examples. That is, what are the common examples? So the common examples. So the first one is what? Our enolate. Our enolate anions. The next one, we talk about our organometallic reagents. So we talk about our halite and our cyanide and the last one. So those are one of the most common examples of our carbanions. The first one is the enolate anion. So in furthermore in our class we will discuss about the enolate anions, our organometallic reagents, our halides, and our cyanides, which are one of the most common carbanion we can find, that we can easily emphasize on. So now the next one we talk about the stabilities of carbanion. That is, the carbanions are relatively stable based on the group, based on the numbers of alkyl parts being attached to them. Like now we are going to compare the secondary, we compare the tertiary carbanions, the secondary carbanions, and the primary carbanions, and the methyl anions itself. That is, how stable are these groups. And also importantly, there's also a specific part we need to discuss. So after the fulfillment of this, which is what the active methylene. That is, on what basis can we say methylene is said to be what active? So what varieties we consider them to be what to be active?
Yeah.
So very good. The next one is the relative stabilities of what? Of our carbanion. So now the stabilities of carbanions varies with the numbers of alkyl group which is attached to our carbon. As you all said earlier, that is, carbon is said to be what? Tetravalent. So now the stability based on the numbers of group which is attached. For example, there's what we call our tertiary group, we have our secondary group, and we have our primary group now. So now the first one here, it says the tertiary carbanion. When we talk about tertiary carbanion, that is a carbon surrounded with 3 alkyl parts. So that is a carbon being what? Surrounded with what? 3 alkyl parts. So that is the carbon bearing the what? Anion is being surrounded with what? 3 alkyl parts, which is least stable due to the presence or due to the surroundings of the alkyl group, which make it what? The least stable. So the next one we can talk about, so which is the secondary carbanion, which is surrounded by 2 alkyl parts. You can see the presence of alkyl parts surrounded by 2 what? Alkyl parts, which is it is quite stable, unlike the tertiary carbanion. So the next one, which is more stable, which is the primary carbanion. It is the primary carbanion, which is just surrounded with with just 1 alkyl group, which makes it more stable than the secondary and the tertiary carbanion. So, and the most stable here is the methyl anions. The methyl anion. And why is it most stable? And why is it said to be most stable? There is no presence of an alkyl group. You just have the hydrogen surrounding it, and the carbon bearing the anion is just surrounded by hydrogen. So which makes it more stable. As we said earlier, that is one of the most common examples of our carbanions. The first one we have here is our enolate anions. What are enolate anions? We say these are formed from the deprotonations of alpha hydrogen in a carbonyl compound. What do we mean by, there's a keyword here which says deprotonations. So what do you mean by deprotonations? That is, deprotonation means removals of protons. And what do we mean by protons? That is, to remove protons. In our normal basic chemistry, we said that hydrogen can also be referred to as protons. That when we talk about deprotonation can simply mean removal of protons. So in simple terms, deprotonation is the removal of protons of alpha hydrogen in a carbonyl compound. That is, the removal of protons of alpha hydrogen is in a carbonyl compound. And there's a question here before, that is, what do we mean by alpha hydrogen? So what is the meaning of that statement? When you say alpha hydrogen in a carbonyl compound, so let's use a ketone group as an example. That is, we have a ketone group. We have a ketone group here, which is being attached with an alkyl part. We have CH2 and CH3, for example now. So in our normal systems of naming, we can say the carbon after the ketone group we can start our labeling. That is the carbon after the ketone group, which is we start our labeling. Unlike our usual chemistry we can say where we can say 1, 2, 3, but this follows a different patterns of naming. But this kind of naming is what is actually different. That is, we start our naming from the after the carbon bearing the what, the ketone group. So we start from here, this one carbon after the what, the ketone group, and we don't just use 1, 2, 3. We make use of what we call our alpha, our beta, and our what, and our gamma. This we can see make use of our alpha, our beta in scenarios where you have 2 and our what, and our gamma. So these are the systems of naming that we are talking about. Now the question now says these are from the protonation of alpha hydrogen in a carbonyl compound. Now let's look, where do we have our alpha hydrogen? We can see the protonation of what, alpha hydrogen. So in this scenario we know that this is our what, our alpha hydrogen. That is, we want to deprotonate. Very good. So now we have these as our examples. One of the examples of our, so we are trying to create what, and acknowledge what, anion. So now the next one talk about our aim is to what, to deprotonate this alpha hydrogen. We are trying to what, deprotonate this what, alpha what, hydrogen, and this can be possible except we bring in a base. Like for example, we can make use of dilute NaOH, that is dilute sodium hydroxide. So we can split it into 2. We have Na plus and what, OH what, minus, and this one can attack and simply attack our methyl group. So we are left with this.